Rise and shine, Mr. Freeman. Rise and shine.
In this problem, two radioactive materials are being compared in an environmental study. Material 1 starts with twice as many atoms as material 2. The half-life of material 1 is half as long as that of material 2. Both materials decay according to first-order radioactive decay, and both are observed over a 20-year period. After 10 years, which material will have a greater reduction of its original amount, and what will that percentage remaining be? So in this problem, the first words that we can pull out might be half-life. Searching for this in the Environmental Reference Manual, version 1.6, will lead you to Chapter 5 in a section called Half-Life Radioactive Decay. Since the materials are decaying at a first-order rate, we can pull the equation from the reference manual as follows, where n equals n sub 0 times e to the minus 0.693 times t over tau, where n sub 0 is the original number of atoms, n is the final number of atoms, t is going to be the time, and tau is going to be the half-life. So the question gives you the 20-year period, but we don't care about that because it's specifically asking over 10 years what material will have a greater reduction. So t in this case is going to be our time of 10 years. Now, if we want to solve this problem out, we can make some assumptions to do so. If you understand half-lives, you probably already know the answer to this question, but if you want to solve the problem out all the way with numbers, there are some assumptions that we can make. So let's take material 1 and material 2, and let's say that the original number of atoms n sub 0 for material 1 is 200, and to satisfy the constraint over here that material 1 starts with twice as many as material 2, material 2 will have 100. Next, the half-life. Same thing. The half-life of material 1 will be half as long as that of 2. So let's just make this 1 year and this 2 years. And now all we have to do is solve this equation above for each one. So for material 1, we're going to say that n equals, our n sub 0 is going to be 200 times e to the minus 0.693 times t, again, is 10 years, and our half-life is going to be 1 year. And this is going to give us a final n of about 0.19. Now, if we divide 0.19 over the initial concentration of 200, we will get 0.00097 or 0.097%. For material 2, let's say that n equals an n sub 0 of 100 times e to the minus 0.693. Again, t will be 10, and our half-life will be 2 years. And this will solve out to about 3.12 atoms. So dividing 3.12 by 100, just skip the middle part and show that this gives us 3.12%. So clearly, material 1 will have a greater reduction in its original amount, and it will be just about 0.1%. Don't confuse that when you round up and accidentally select 0.01 instead. So this problem is really easy to solve. This question is mostly just being presented to you to get you familiar with where radioactive decay and half-lives are in the reference manual, as well as giving people who are maybe experienced with this an instant recognition that material 1 is going to be the faster of the two to decay just because of its smaller half-life. And that's all it takes to solve this problem.
Wake up, Mr. Freeman. Wake up and smell the ashes.